lot of people have given up, kind of point blank. People who really, really care about climate and realize, hey, I don't think we're going to do this. The political headwinds, this isn't going to be possible.
What we do in the next few years will determine the next few thousand.
I actually do think we're going to solve this problem. And I think we see the potential not just to avoid a worst case, but to actually build a much better future. If we look back at geologic time and we say, how has Earth done this over the last billion years? Rocks have been one of the primary drivers of pulling CO2 out of the atmosphere. It's this process called rock weathering that has largely regulated global CO2.
The rocks that are all around us are actually having a big imprint over geologic time on the climate. If we simply take them and use them to our advantage, we can draw CO2 out of the atmosphere. In essence, what happens during tectonic periods where we have lots of mountains being built, you're getting rocks that are exposed. As it reacts with rainwater, so as rainwater is percolating down in, it starts to dissolve the rock. And when it dissolves the rock, that actually takes CO2 and transfers it into the water. You pull CO2 out of the atmosphere into that water as bicarbonate. That water continues to percolate on down, ultimately goes out to a stream, a river, and then the ocean, and stores it for thousands and thousands of years. The Himalayas are actually a really good representation of one of the more recent mountain building processes, and you can see then that process, as it exposes more rock, will lead to CO2 drawdown. What we're trying to do is emulate that same reaction that we have seen over geologic time, but put it under human time scale. And the way we do that is we take the rock and we grind it up and put it in a soil environment where it's going to react quickly.
We take those same rocks, we crush them up and spread it on farmland, and we can go from a boulder that would have removed carbon over, say, 100,000 years to remove most of the carbon in 2 to 3.
Olá, meu nome é Marisa Sekula. Eu sou cofundadora e CFO da Terradot. We've started in Brazil. We picked Brazil because enhanced rock weathering performs best in tropical conditions, so a lot of rain, a lot of humidity. Second, in Brazil, you have sophisticated agriculture, sophisticated quarry networks that mean we have quick access into that existing infrastructure. And finally, Brazil has a predominantly clean grid. 93% was the last year. And so what that means is all the machinery we need to crush the rock is not emitting carbon as much as it would in any other region of the world.
So today we just received 5 trucks of rock powder, 45 tons each. We are going to start to spread all this rock powder today.
While we're spreading this rock on farmland to remove carbon, it also has enormous agricultural benefit for farmers. It helps improve naturally acidic soils, manages the pH. And second, the minerals, other micronutrients that are actually in that rock, they help to improve the general soil health as well.
So we know enhanced rock weathering works. The challenge is actually measuring how much carbon it's captured to show that you can do it affordably and reliably.
Right now at Terradot, we're working hard to prove that we can deliver enhanced rock weathering credits to the world. Our challenge is then building an MRV that allows us to know beyond reasonable doubt that when we say 1 ton of carbon's been removed, it actually has been.
The MRV stands for measurement, reporting, and verification. So first of all, we need to measure the carbon impacts that our projects are having.
We're taking plant samples, we're taking water samples, and we're doing very high precision analysis.
A gente abre 2 metros por vez, a gente fotografa, a gente descreve, pega no mínimo uma amostra.
They've got a well-oiled machine out there handling thousands of soil samples, thousands of bags of cores. We can send them the plans so that they know where to sample and how to design these experiments on the ground.
Powered by Terradot's technology, we can demonstrate where we think this will work best, definitively quantify how much carbon's been removed, and in doing that, make this investable and deploy ERW at a scale that matters to impact the climate crisis.
You can think of this quarry and the surrounding farmland kind of like a carbon removal hub that just hasn't been turned on yet. We've identified thousands of hubs just like this one all around the world that could be turned on to generate billions of tons of carbon removal.
I think as scientists, we need to really impress upon ourselves the challenge of the day, which is to get to scale. In the many gigatons, right now is where we see a global potential getting to.
COP is putting the world's attention on Brazil. And that creates a huge opportunity for a solution like this to potentially be highlighted all around the world.
A gente tem todos os ingredientes para tornar isso o maior palco para esse tipo de projeto, esse tipo de solução. All of this momentum that is bringing together agriculture, the mining industry, scalable financing solutions, government, it's in that coalition and in that partnership of players that we're actually going to be able to turn on this infrastructure incredibly fast.
What we're seeing every day is progress is possible. If we can get the world to band together, we can actually have a planetary scale solution.